Simplify 9 square roots of 14 minus 8 square roots of 14. So whenever we're adding or subtracting radicals, they have to be like. So being like means that the radicand are the same and the coefficients are like terms as well. So here, since they're both true, that they're both like, we have 9 square roots of 14 and we're taking away 8 square roots of 14. So that would leave us 1 square root of 14 or just plain square root of 14. Okay, next problem. We're simplifying the square root of 98 plus 2 times the square root of 32. So in their current form, they're not like. So we're going to simplify each one. So the square root of 98 can be rewritten as the square root of 49 times the square root of 2. And the square root of 49 we know to be 7. So the square root of 98 is 7 square roots of 2. Next, we need to simplify 2 square roots of 32. So the highest perfect square factor of 32 is 16. So we rewrite 2 square roots of 32 as 2 times the square root of 16 times the square root of 2. The square root of 16 is 4. So 2 times 4 would give us 8 square roots of 2. So we're adding 7 square roots of 2 to 8 square roots of 2. And again, since the radicands are the same and the coefficients are like, we can go ahead and add. If we have 7 square roots of 2 and we get 8 more square roots of 2, we have 15 square roots of 2. So next, we'll look at some multiplication. Here we have the square root of 7 times the square root of 2. So we can multiply the radicands together, the 7 and 2, and this would give us the square root of 14. Since 14 doesn't have any perfect square factors except for 1, then we are simplified as much as we can. Another multiplication problem. We're asked to simplify the square root of 6 times the square root of 12. So we multiply the radicands together, and this gives us the square root of 72. Now 72 does have a perfect square factor other than 1, and so we rewrite it as the square root of 36 times the square root of 2. We can simplify. The square root of 36 is 6. So our final answer would be 6 square roots of 2. Next, we're asked to multiply the square root of 5c times the square root of 5c. So when we're dealing with square roots, when you multiply a radical times itself, what it will do is remove the radical sign. So the square root of 5c times the square root of 5c is 5c. So if we had the square root of 17 times the square root of 17, then our answer would be 17. Next, multiply 9 square roots of 2 times the quantity, the square root of 10 minus the square root of 3. So here, we're going to use the distributive property and then simplify at the end. So 9 square roots of 2 times the square root of 10 is 9 square roots of 20. 9 square roots of 2 times negative 1 square roots of 3 gives us negative 9 square roots of 6. Now the square root of 20 does have a perfect square factor, so we're going to rewrite 9 square roots of 20 to 9 square roots of 4 times the square root of 5. Now the square root of 6 doesn't have a perfect square factor other than 1, so we leave that and it's already simplified. Now we go further. With 9, the square root of 4 is 2. So we have 9 times 2 times the square root of 5 minus 9 times the square root of 6. 9 times 2 is 18. So we have 18 square roots of 5 minus 9 square roots of 6. Since these are not like, that would be our final answer. 18 square roots of 5 minus 9 square roots of 6. Next, we're asked to multiply 2 square roots of 10 plus 4 times the quantity square root of 5 plus 2. So we're going to use the distributive property again, starting with 2 square roots of 10, and we're going to multiply it times both of the terms in the second parentheses. So 2 square roots of 10 times the square root of 5 gives us 2 square roots of 50. 2 square roots of 10 times positive 2 gives us positive 4 square roots of 10. So next we distribute the positive 4 times both. So positive 4 times the square root of 5 is positive 4 square roots of 5. And positive 4 times positive 2 is positive 8. So we're going to simplify whatever we can. So the only one that has a perfect square factor is 50. So we're going to go ahead and simplify and rewrite the square root of 50 as the square root of 25 times the square root of 2. And the other three remain unchanged. So we know the square root of 25 is 5. So this gives us 2 times 5 times the square root of 2 plus 4 square roots of 10 plus 4 square roots of 5 plus 8. And we know 2 times 5 is 10. So we have 10 square roots of 2 plus 4 square roots of 10 plus 4 square roots of 5 plus 8. Since they're all simplified, there's no like terms, so that would be our final answer. Next, we're asked to multiply the quantity square root of 5 minus 2 times the quantity the square root of 5 plus 2. So we're going to go ahead and use the distributive property again. And so we start by multiplying the square root of 5 times both terms. So the square root of 5 times itself, remember, we'll remove the radical sign. The square root of 5 times positive 2 gives us 2 square roots of 5. Next, we're going to distribute the negative 2 times both. So negative 2 times the square root of 5 gives us negative 2 square roots of 5. And negative 2 times positive 2 is negative 4. So next we would simplify and then combine like terms. There's nothing to simplify, but our two like terms are our middle terms. 2 square roots of 5 minus 2 square roots of 5 cancels out. So that leaves us with 5 minus 4, which is 1. Now this is significant, and we're going to use this to rationalize The square root of 5 minus 2 and the square root of 5 plus 2 are called conjugates of one another. And when we multiply a factor times its conjugate, notice what happens to our radical. Our radical is eliminated, leaving us with an integer, in this case 1. So whenever we want to get rid of a radical and we're dealing with binomials in this course, we're going to multiply by its conjugate in order to rationalize or change it into a rational number or an integer in this case. So next we're going to talk about rationalizing. Rationalizing means to change a value from an irrational number, that's a number under the radical, to a value that's no longer under the radical. Now, we're going to go back to what we talked about earlier when we multiplied the square root of 5c times itself. The reason that it removes it from underneath the radical sign is because it creates a perfect square. So what we're going to be doing when we're rationalizing the denominator is creating a perfect square with our denominator whenever we're dealing with a monomial. So in this case, to rationalize, if I multiply the square root of 7 times itself, it will remove the radical. Now what I do to the denominator, I also do to the numerator as well, because anything over itself is 1, so I'm not changing any value. So now 4 times the square root of 7 is 4 square roots of 7. And again, the square root of 7 times itself becomes a perfect square, which is 49, but it simplifies to 7. Now we have a binomial in our denominator. So we can no longer use the process we just learned. Instead, we're going to go back to that concept of the conjugate. So if I want to rationalize this denominator, I need to multiply by its conjugate. And its conjugate just means that the sign will change from a minus to a plus and vice versa. So I multiply numerator and denominator by the conjugate of the denominator. So I'm multiplying by 6 plus 3 square roots of 2. In the numerator, I'm going to distribute the 5 times each. So 5 times 6 is 30, and 5 times 3 square roots of 2 would give me positive 15 square roots of 2. Now when I'm multiplying out my denominator, since I'm multiplying by its conjugate, I don't really need to go through the whole process of the distributive property because we know the middle term will be eliminated. So anytime you're multiplying a factor times its conjugate, as we're doing here, all you have to do is multiply the first two together. So 6 times 6 is 36. And the last two together. So a negative times a positive is a negative. And 3 square roots of 2 times 3 square roots of 2 give us 9 times 2. And you say, where does that 2 come from? Remember, if I'm multiplying the square root of 2 times itself, it becomes a perfect square and removes the radical. So now I have 30 plus 15 square roots of 2 in the numerator. And in the denominator, I have 36 minus 18. So in the numerator, 30 plus 15 square roots of 2. And in the denominator, 36 minus 18 is 18. Now I reduce if possible. If something divides into 30, 15, and 18, then I can reduce this. And 3 divides into all 3, so I'm going to divide a 3 out of 30, which gives me 10. a 3 out of 15, which gives me 5, and a 3 out of 18, which gives me 6. So my final answer will be 10 plus 5 square roots of 2 over 6. Let's look at another one. Here we're asked to rationalize the denominator and simplify. We have the square root of 11 minus the square root of 5 in the numerator. And in the denominator, we have the square root of 11 plus the square root of 5. So I'm going to put these in parentheses. And since I'm rationalizing the denominator, I'm going to multiply by the conjugate. So remember, all I'm going to do is just change the sign. And what I do to the denominator, I do to the numerator as well. So in the numerator, I need to use the distributive property. So I start by taking the square root of 11 times both of the terms in the other parentheses. So the square root of 11 times itself, remember, removes the radical sign because it becomes a perfect square. And the square root of 11 times negative square root of 5 gives me negative 1 square roots of 55. Next, I'm going to distribute the negative square root of 5 times both. So negative 1 square root of 5 times the square root of 11 once again gives me negative 1 square roots of 55. And then negative square root of 5 times negative square root of 5 gives me positive 5, because a negative times a negative is a positive, and the square root of 5 times itself becomes 5. Now in my denominator, remember, I'm multiplying a factor times its conjugate. So in this case, all I need to do is multiply the first two together and the last two together. So the square root of 11 times itself is 11. And positive square root of 5 times negative square root of 5 gives me a negative 5. So I'm going to collect like terms. So in the numerator, I have 11 plus 5, which is 16. I have negative 1 square root of 55 and negative 1 square root of 55, which gives me negative 2 square roots of 55. I don't add the radicands, I just add the coefficients. And in my denominator, I have 11 minus 5, which is 6. Now my last step is to see if a factor divides evenly into 16, 2, and 6, and 2 does. So I divide 2 out of each. So 16 divided by 2 is 8, 2 divided by 2 is 1, and 6 divided by 2 is 3. So my final answer is 8 minus 1 square root of 55. I don't need to show the coefficient 1, all over 3. Next, we're going to get into solving radical equations. So we have the square root of w equals 5. So what we want to do is isolate the radical. It's already by itself. Nothing's added, subtracted, or multiplied times it. So next, I'll remove the radical. Since we're talking about square root, in order to get rid of the radical, I square both sides. So on the left-hand side, it removes the radical, leaves me with w. And on the right-hand side, 5 to the second power is 25. So if this happened to have been the cube root of w equals 5, in order to eliminate the cube root, I raise both sides to the third power. So that would give me w equals 125. The next problem. I have negative 5 plus the square root of y plus 3 equals 2. So the first thing we want to do is isolate our radical. So I'm going to add 5 to both sides. And this would give me the square root of y plus 3 equals 7. Now, since I'm dealing with square root and I want to eliminate the radical sign, I'm going to square both sides. So on the left-hand side, that leaves me with y plus 3 because that just removed the radical sign. And 7 to the second power is 49. I'm going to subtract 3 from both sides in order to solve for y. So y would equal 46. My next problem, I have u equals the square root of 7u minus 10. So the process is going to be the same. Since the radical is already isolated, in order to eliminate it, I'm going to square both sides. So that gives me u squared equals 7u minus 10. Now, since I have a quadratic equation, it's u is raised to the second power, I need to set this equation to 0. So I'm going to move the 7u and the negative 10 on the other side by taking their opposite. So positive 7u when I moved it to the left of the equal sign became negative, and negative 10 when I moved it to the left, it changed to a positive 10. Now we need to factor. So we're looking for the factors of positive 10 that add to a negative 7. So the two numbers that multiply to give me a positive 10 and add to a negative 7 would be a negative 2 and a negative 5. So we finish by setting each one of these factors to 0 and solve. So we get u equals 2 and u equals 5. Our last concept is that of dealing with the complex number system. When we're dealing with real numbers, as we talked about earlier, if we have a negative underneath a radical, we said that there was no solution since there's no value in the real number system where we multiply it times itself to give us negative 4. Now, under the set of the complex numbers, we use an I to represent the square root of negative 1. So we're going to simplify primarily the same way as we normally do, with one exception. Okay, so under the set of complex numbers, we can have a negative under the radical. So what we do is we rewrite it as the square root of negative 1 times the square root, in this case, of 9. Now, in place of the square root of negative 1, we put I. And we know what the square root of 9 is. It's 3. So we write our answer not as I times 3, but as 3I. Okay, our next example, we're asked to simplify the square root of negative 12. So again, what we're going to do is rewrite negative 12 as the square root of 1 times the square root of 12. Now, 12 does have a perfect square factor. It's not a perfect square, but it does have a perfect square factor. So we rewrite 12 as the square root of 4 times the square root of 3. Okay, we know that square root of -1 is I. We know the square root of 4 is 2. And the square root of 3 is simplified as much as it can be. So our final answer, instead of writing it I times 2, we write it as 2I times the square root of 3.